Welcome everyone. We are here to look at the t-sql apply operator with Itzik. He's a SQL Server MVP and t-sql trainer. He's going to explain about how the apply operator works and how it differs from inner join and other operators. I will hand it over to Itzik to introduce himself first.
Thanks, UC. So essentially the session is about a table operator, just like joins are table operators, also cross-apply and outer-apply are table operators. And for some strange reason, it seems that the operator is off the radar for many people. It was actually introduced in SQL Server 2005 already. And back then when it was introduced, it was over a decade ago, right? So, when I teach about t-sql, I usually do a quick show of hands. How many people know of the apply operator? How many people already use the apply operator? And I see a very small percentage. So you see 20% of people maybe already know and use it. So nowadays, I use it in so many of my solutions that it's still a puzzle to me. But anyway, we're trying to fix this with this session and show you how powerful this operator is. And you will see that once you get to know it, it's one of those things that you cannot stop, using them. So just a few words about myself, and then Yussi will introduce himself before we actually start with the technical part. So I'm mainly a t-sql trainer for SolidQ these days. I teach two main kinds of courses. One is an advanced t-sql class that runs for 5 days, and another is a 4-day fundamentals class. So I basically travel around the world doing these kinds of courses. My background is about 20 years of experience with databases, SQL Server mainly. This is my expertise. And in the last decade and a half, I would say, my focus has been mainly the language part. So t-sql and anything that has to do with making the t-sql code run fast. So optimization side of things, tuning, physical structures, how to write efficient code, that's pretty much me. So I've written quite a lot of books about t-sql and just starting a new one with the improvements in 2012 and 2014 as well. And let me hand it to Yussi.
Hi, my name is Umachandar. I am a program manager in the SQL Server product group. I am currently working on Windows Azure SQL database. I started working with SQL Server since '94 and other database products. I'm familiar with most of the operators and t-sql functionality in SQL Server. So back to Itzik.
So by the way, I don't know if you noticed the accent, but both Yussi and I have the same mother tongue, which is t-sql, right? Yeah. And I feel more comfortable with t-sql than any other language. And Yussi is one of those people that I think know t-sql best on this planet. So we feel very, very comfortable communicating. Yeah. All right, so the course is organized as two main parts. So we have the first part where we provide the foundations, explain what the apply operator is. And to do so, we'll start by just remembering those very familiar join operators, cross join, inner join, and then relate this to the apply operator and show what kinds of things the joins are not capable of doing and the apply actually allows you to do. So this will be the first part, and I'll show a fairly simple example just to demonstrate this. And with this, we will conclude the first part, just essentially laying the foundations. Then the second part will be the bulk of the course. In this part, we'll go through different features that we have available in SQL Server. Each of them was introduced in a different version of the product. So we thought it would be interesting to show how features that were introduced in 7.0, in 2000, in 2005, 2008, 2012, that people use quite often, how we can boost them, how we can improve them by combining them with this apply operator. Right? So this will be the second part that will take the majority of the course, basically. All right, so let's get started with the first part about the foundations, but just to give you a sense about expectations, background that you should have before you see this session. So the course is intended for people that do have some experience already. The assumption is that you are familiar with the classic, let's say, SQL constructs, mainly joins and the subqueries, including correlated subqueries, which you will see a very strong relationship to the apply operator. So I'm assuming that you are very comfortable with joins and the subqueries, especially the correlated ones. And let's say that you have around half a year of experience working with t-sql, including optimization aspects. So you're familiar with looking at query execution plans. You're familiar with what an index scan is, what an index seek is, what the lookup is, and generally you are comfortable with analyzing query execution plans. In terms of prerequisites, for one, I have a book that covers t-sql fundamentals. I'm assuming that you have kind of parallel knowledge that appears in this book that describes the different constructs. And also, to download the source code for this course, you have a link in the slide to a website called t-sql.solidq.com, and within this website there's a section called resources, and within it there's a section called source code for recent conferences and sessions. And anyway, you have also the direct link on this slide, right? So in general, the way the course is organized, I believe more in demonstrating code and less in looking at slides. I think people relate to code better and learn better this way. So in many of the examples, I will develop the solutions from scratch, showing how the thought process, involved in those solutions. All right. So that's in terms of expectations. And then generally with the Microsoft Virtual Academy community, this is a free online learning tailored for IT pros and developers. There are already more than 1 million subscribers, and now there's a new course that you can obtain from this media. So let's get started with the first part, providing the foundations for the apply operator. And by the way, a nice perspective that we have with Yussi being here is besides being a program manager directly involved in t-sql development and so on and giving us the Microsoft perspective, also Yussi is a member of the ANSI SQL committee, so it would be interesting in some cases to talk about a relationship of the constructs that we will discuss to standard SQL and looking what the standard has to offer in the different areas, right? So let's get started with understanding, first of all, how joins are designed, and because the apply operator in some sense is similar to joins, for one, because it's designed as a table operator, just like a join is an operator that appears within the from clause of a query, apply is also a table operator that appears in the from clause of a query. So let's first get to look at how joins are designed, and then we'll talk about what are the limitations of joins and how apply gets to solve those. So let's start with a simple cross join as an example. Then let's look at inner joins, and then we'll understand how apply relates to them. So if we look at the cross join as an example, a cross join essentially gives us the combinations of the rows from both sets. So we go and write a query, select some columns from some table. Let's say that we had a table called T1, and we had these columns from this table, and we have another table called T2. So select from some table T2, and now I wanted to go and return all combinations from these two tables. I would go and write a select from T1 and then a cross join with a select from some T2, and then go and collect elements from the different sides. So T1 column 1, T2 dot column 1, and then basically what we would get are all combinations of rows from the two sides. So if I have 5 rows in T1 and 10 rows in T2, we're going to get 50 rows basically in the result. So as a more concrete example for a cross join, let's say that we have a table holding information about customers. So I'll use a sample database called t-sql 2012. And by the way, in the source code that you will download, you will see links to download specific source code to create different sample databases that are used within the demos, right? So just make sure that you install them before you run the examples that I'm demonstrating. So t-sql 2012 is a sample database that is based originally on the Northwind sample database. It's a database that Microsoft used for both Access historically and for some previous versions of SQL Server. And this sample database is built basically on top of the Northwind database. So we have a table holding information about customers. And then within this database, I also have a table function called getNums. GetNums is a very handy auxiliary function that accepts as inputs some kind of a low value and some kind of a high value, and it simply generates a sequence of integers within this range. So for example, if I provided 1 as the low value and 10 as the high value, you see the result consisting of 10 numbers. Now, let's suppose that we need to generate a report that shows activity for customers in different years. And I first need to generate this kind of template for my report that has a row per customer and a column per year in the range 2012 to 2014. So from the function, I will go and collect the years 2012 through 2014. And now what I want to do is take all customers and all years within this range and then generate all possible combinations. And that's exactly where a cross join will help us. We'll go and say select from customers, and maybe let's call it C in short, and then do a cross join with our DBO getNums function, providing the years 2012 through 2014 as the inputs, and this will be Y for years. And then from the customer side, I'll collect maybe the customer ID and the company name. And then from the Y side, I'll collect the number representing, let's say, an order year. And now you will see how we get 273 rows, because it's 91 rows in the customers table and 3 rows in our years table. So to summarize what a cross join is, we use 2 predefined sets as our inputs. And then the cross join simply gives us the combinations of these 2 sets. So 3 rows in one, 91 rows in the other, and then we have 273 rows basically in the combination. So the critical thing to remember about the join part before we relate it to the apply operator is the fact that the 2 sets are predefined. It's not that one set is evaluated first and the other set is evaluated second. It's not that one set is evaluated based on elements from the other set. Think about 2 sets or 2 relations that are predefined, and then we go and generate all combinations. Right? So this is pretty much a cross join. Then let's talk about an inner join. An inner join also gives us 2 sets that are predefined, but then as if we generate all possible combinations, but then apply some kind of a predicate, some kind of a condition that gives us only matches that are based on this sort of condition. So for example, if I take our customers table, and then I'll take the orders table. So remember, in the customers table, we have 91 customers. In the orders table, we have 830 orders. And you will notice that the orders were placed by some customer, of course. And now we want to go and connect customers and the related orders. For this, we have an inner join. So what we will do is we will say select from sales.customers. Let's call it C in short, then do an inner join between sales customers and sales orders. And then we have a predicate, what we don't have in a cross join, that relates the orders to the respective customers. So C.custID equals O.custID. And in some literature, the way an inner join is described is actually as if we have first a cross join between the 2 relations, and then we apply a predicate that filters the rows from this Cartesian product that we have from the 2 sides. So now we can go and collect from the matches any information that we like the customer ID and the company name from the customer side, and then from the order side, let's collect the order ID, maybe the order date, and so on. So you will see that what we get in the result are only the matching combinations. So again, what's special about the inner join, for one, like the cross join, it is concerned with two predefined sets. So also here we have a predefined set of customers, a predefined set of orders, and then we have the extra that we don't have in a cross join, which is a predicate that filters only the interesting matches. All right? So in both a cross and an inner join, we can say that the two input components for the join are predefined sets. And now let's try and think about what the join cannot do. And for this, we will use the apply operator to solve our problem. So what the join cannot do is take one set that is predefined, but then have the other set be created separately for each row in the left set based on elements that we collect from the left set. So if this doesn't make much sense, let's look at an example. So for example, let's say that instead of matching all orders with the respective customers, what we want to do is for each customer, we want to return only a certain number of its most recent orders, right? And let's say that we have a query that for a given customer returns a certain number of most recent orders. So let's do it like this. We'll write a select top of some number. Let's take 3 as an example of information about the order. So order ID, order date, maybe the employee ID from orders where the customer ID is equal to some specific customer. So here you can see that I returned 3 orders for some customer, and now to make those the 3 most recent orders, the top operator will need an order specification. So we'll say order by order date descending, and then order ID descending. And as you can see, what we got now are the 3 most recent orders for customer 1. And now let's say that I want to encapsulate this logic within a table function. So I'll go ahead and create one. So just to make sure we don't have one already. And now let's go ahead and create a function called getTopOrders that accepts a customer ID as input, as well as a number of most recent orders that we want to return. And then the function returns a table. And what it has is just a return clause that returns the result of this query, only of course referring to the input parameters that we pass to the function. And just an important note before we talk about how we involve apply in this is that this particular example is not that critical to understand the apply operator. I'm just using it as a vehicle to demonstrate the idea. But just think about any kind of table expression or table function that its logic could be essentially anything. In this case, it happens to be return the n most recent orders for a given customer, but think about any table function that returns any kind of a result set. So now that our logic is encapsulated in a function, if I wanted to go ahead and return the 3 most recent orders for customer 1, I would say select from our function and then pass customer 1 as input and the number 3 as input, and then the result, as you can see, are the 3 most recent orders for the customer 1. Now imagine that, never mind how the logic was implemented within the function, I wanted to go ahead and return the 3 most recent orders for each of my customers. Now remember that both in a cross join and in an inner join, the sets have to be predefined. Here what I want to do is I want to go and query the customers table as my left set. Let's call it C in short. Now I cannot say cross join and then my function, because the inputs to the function are not static inputs. I actually need those inputs. Let's call it maybe O for order. So the inputs are supposed to be inputs that I'm collecting from the left row. So cast ID as the customer ID, and the number 3 in this case would still be the constant number. Why can't this work? Because this element I need to collect from the left row, and the left row therefore has to be evaluated before I'm activating the right side. So in a sense, what I'm looking for is something similar to a cross join, but such an activity that will evaluate the left set first, and then for each of its rows will go and apply the right table function. So in a sense, it's like performing a cross join per row from the left side separately, but first look at the left row, evaluate it first, collect some element from it, and then activate the right side, right? So if you try to do a cross join here, let's go and actually try to see that it doesn't work. So let's return cast ID, company name from the left side, and then from the right side, let's return the order ID, the order date, and maybe the employee ID. And now let's make an attempt to run this query, and notice we get an error saying multi-part identifier cast ID could not be bound. The meaning of the error is that we're trying to refer to something that as if doesn't yet exist, because remember, in the cross join both sets have to be predefined, and it's not like we can rely on a component or an element from the left side when we are evaluating the right side. So in essence, we need something very similar to a cross join, but one that does the left side evaluation first, and then the right side is activated kind of per row from the left side, right? And that's exactly where cross-apply solves our problem. That's exactly what cross-apply does. So now we go evaluate customers first, as if we look at each row in the customer side separately, and then collect an element from the row, pass it here, and we can think of this element much like a correlation. Take the customer ID from the customer row, then evaluate the right side. For that row, generate the result, and then look at another row. Now in reality, it's not like it has to happen like this, that we look at the left rows one at a time. In reality, or I should say more conceptually actually, the evaluation does happen in this sort of all-at-once manner. So try to visualize all customer rows in this all-at-once manner, and that this right side gets applied to each of those as if at the same point in time. Of course, for many people, it's easier to think in terms of a cursor, as if we went with a cursor against the individual rows within the customers table, collected the customer ID, activated the function, generated the result, and moved on to the next customer, right? So when we go ahead and run this, then you can see how for customer 72, we got the 3 most recent orders. For customer 58, we got the 3 most recent orders. And then the part that is similar to a join is that we can return information from both sides. We can return elements from the left row, the customer row, and we can return elements from the right side, and that's the order itself, right? So that's in essence what the cross-apply is. So what we looked at is the most basic form of a cross-apply. We go and look at the rows from the left side and apply the right table expression, or in this case, table function, against the different rows in the left side. So this is the so-called cross-apply operator. Now we have a couple of other versions of the apply operator. One thing that the cross-apply does not return is, imagine that we have some rows in the customers table that simply don't have any related rows in the order side. In that case, the left row is actually discarded. So in this sense, it's actually similar to an inner join. If we have a customer that doesn't have any matching orders, an inner join doesn't return such a customer. In a similar manner, in a cross-apply, if the customer gets 0 rows back from the function, then the left row, the customer row, is not returned either. By the way, the cross-apply operator is an operator that is specific to t-SQL, but I was wondering, Yussi, if there's anything in the standard that is similar to the apply operator.
Yeah, the standard actually has a different operator by name lateral. It's the same thing as apply. When we designed the feature at that time, some of the versions of the standard were still in draft. So we went and basically picked a name for it.
You would write it in a similar manner? So
yeah, so if we were to write it in ANSI standard, essentially this will just say lateral instead of...
So something like this, cross-join lateral?
Yes. So basically it's considered like a table operator, and that's how it would kind of look. We still have an opportunity at some point to probably introduce the standard specific syntax.
Right. So in other words, if anyone is migrating a system from another platform, more likely they will have lateral and they will need to convert it to this cross-apply, basically.
Yeah. Today, I think only Postgres probably implements it. DB2 doesn't. I mean, nobody has this. So, yeah.
All right. Cool. So now let's look at the second version of the apply operator. So remember, cross-apply, if we have a left row that doesn't have any rows coming back from the right side, then the left row is not returned either. So much like there are different versions of joins, we have a cross join, we have an inner join that returns only matches, and then we have an outer join that preserves rows from what we marked as the preserved side. If we said left outer join, we mark the left side as preserved. In a similar manner, we have an outer version of apply that simply says do not discard left rows if they get 0 matches from the right side. So let's say the cross-apply operator that we used returned 263 rows. We have a couple of customers that don't have any related orders. So now let's go and change it to outer apply. And now we should find a few extra rows. So you see now the number of rows returned is actually not 263, it's 265. So we have there a couple of extra customers. We can scroll down and look for them here. So you can see, for example, customer 22 has no related orders. And this time we did preserve it, unlike with the inner apply. So you see it's a bit interesting why you decided to call the cross-apply operator cross-apply, not inner apply, if actually cross-apply behaves, it seems more like an inner join, that if there are no matches, it doesn't return the row.
I don't know. There is no real reason other than probably some of the implementation.
So it
how
seems
we parse the syntax and so on.
But in a sense, it does seem like cross-apply does something similar to a cross-join, but per row.
Yeah, I mean,
right?
And the other reason is if you look at the syntax, just like cross-join, the predicate is not specified immediately after the join operator, right? Whereas an inner join and on clause is kind of mandatory. And here, by referencing the left side input, you have an implicit join.
Right.
I mean, you could still apply a further predicates by putting a where clause.
Right.
In that sense, it's more closer to a cross join. Because the typical case would be just you pass, like here in this example, like a customer ID, right? The column as reference.
Yeah, so maybe an easy way to try and visualize this is if I look at the customers table, to try and relate it to a cross join, I'll pick one customer, then I'll go invoke the function.
For that
I'll get,
customer,
let's say, 3 rows, and then it's as if I'm doing a cross join between this one row from customers
and then all the 3. Yeah.
So in this perspective, it's actually more similar to a cross join. So I guess we could essentially do a cross join indirectly by doing a cross apply just without any predicate.
Yeah,
so something like
sure.
So this effectively should give me exactly the same thing as a cross join, right?
Yes.
Yeah?
Yep.
So we have 75,530 rows because we're multiplying 91 rows in customers and 800
There is no
rows.
implicit reference. It's like basically everything from left side.
So in the standard, therefore, I imagine, or those platforms who did implement the lateral operator, I would imagine this should look something like a outer
so you
join.
just say,
so
that one would be outer join,
outer
up,
join,
lateral,
and then lateral.
Yeah.
And then actually you still would need the predicate, right? So some dummy predicate
which is like 1 equal to 1.
Equals 1.
Yeah.
So this is how those platforms that implemented an explicit lateral, that's how it would look like.
They're basically in the standard, it's defined as a table reference.
Right.
Whereas we implemented it as an operator. So, I mean, I guess that's probably where the difference comes from.
All right. So it's still quite easy to migrate.
Yeah, sure.
So it's pretty straightforward.
Easily transform the syntax, yes.
All right, so this would be the outer apply operator that basically adds a logical phase to the cross apply operator where we preserve the left rows even if we didn't get any matches back from the right side. And then there's a third version of the apply operator, but one that doesn't explicitly use the apply operator anyway or anywhere, but still the logic and the concept is very, very similar to apply. And in fact, before the apply operator was added to the engine, actually this activity didn't work. So let's see what is this sort of implied apply or implicit apply. So let's say that we wanted to go ahead and query our customers table and return the customer ID and maybe the company name. And now, in addition, I want to return for each of my customers also how many distinct employees handled the customer's last X orders. Let's say last 10 orders or last 3 orders, yeah? So how many employees? Now, I know that if I used an explicit apply, I could obtain each customer's last 10 orders by going and doing an apply to my function, right? So I could go ahead and say select, let's take employee ID from sales get top orders. And then remember, we pass some kind of a customer ID, we pass how many orders we want, and then what we get back are those orders. So here you can see the different employee IDs that appear in the customer's last 10 orders, if there were 10 orders. Of course, in this case, you see there were fewer orders. And now I could obviously go and say count distinct employee ID in those orders. So what I want to do is I want to take this logic, and instead of applying it to the constant one, I want to apply it to the customer ID that I'm collecting from the customer's table. So basically placing it right over here in this sort of, in a sense, correlated table subquery, right? So what I'm doing here is, here I'm passing CCAS ID from the customer's table. Even though I'm not doing this using an explicit apply, it's the exact same concept like apply, because essentially I'm applying the table function to each row from the underlying table in the query. And as you can see, it simply works. So customer 72 had 7 distinct employees handling its last 10 orders. Customer 58 had 5 distinct employees handling its last 5 orders, and so on. So this is what I will refer to later in the course as this sort of implicit apply, where in a sentence what we are doing is we are referring to a table function within a subquery, and we are passing a column from the underlying table as input. Same idea, same technology that is used to process apply is used also to process this kind of activity. All right? So that's in essence implicit apply, and this pretty much concludes the first part that provides the fundamentals for the apply operator. So quite a strong operator, I would say.
Yep.
You know, so
very interesting and quite powerful too.
Right, and I believe you added it to the product in conjunction with the addition of all those dynamic management views, functions, and so on, where it can be very handy, right?
Yeah, especially where you want to correlate, like from tables to columns, or various DMVs which collect or which require certain input from outside, right?
Right.
So you could filter those and then.
Right. Yeah. Maybe one example that pops to mind is. There's a dynamic management function that returns attributes of a query plan. Mm-hmm, it's called sys.dm exec plan attributes. And then you have a DMV called sys.dm exec query stats that gives you the different performance statistics for queries, and there is a plan handle
and
that
then
you can then
pass that,
go ahead and pass it to the DM plan attributes, right?
Yep.
Yeah.
So it's quite useful. Yeah.
All right. So with this, we conclude the first part about the apply operator and its fundamentals. So to recap, we had the cross apply that returns the result rows from a function that we apply to each row from some left table, but does not return the left row if the right side returns an empty set. And then we have outer apply that, in addition to what cross apply does, preserves the left rows, even if they got 0 rows back from the right side. And then we have implicit apply, where we refer to a table function within a subquery, and we pass a column from the underlying table as input. So even though we're not saying apply anywhere, we're using essentially the same technology.
Thanks, Itzik, for a great overview of the apply operator. In the second session, we'll go and look at specific examples of how apply operator works with various new features added in SQL Server over different versions.